Knight KG664 high voltage regulated power supply. I'm going to give you some tips on fixing one of these up. First of all, you're going to want to clean and lubricate all of the switches. Both steps are important. You can't just clean these with deoxit or contact spray. That won't work. You only get maybe a month, maybe less, before they'll start to get scratchy and have poor performance. So what you're going to want to do on these, you'll tilt the unit up or take it out. You want to get some lube down in these, something like a CRC 226, but you need to get lubrication down in this. I wouldn't use any type of 3-in-1 oil. That doesn't really seem to work that well. You want to stick with something that's electrical grade but a lubricant. Also works excellent is the new WD-40 gel lubricant. Make sure you buy the gel lubricant. And so what you're going to do is you can get the contact spray or deoxit, spray it through here, and if you push these in, you'll see some space that opens up. Get it in there. You can soak it down. It doesn't hurt it. Same thing with these switches. So then when you open these, the unit up, you'll get some spray here into these switches, the slide switches. Okay, so when you open the unit up, you're going to want to get some cleaner first and then lubricant into the slide switches and just work them a lot. You want to make sure they're nice and clean. You'll probably have to tighten up the terminals on the meters. I find that these are almost always loose. Okay, you'll see a natural line voltage variation because this is plugged into an ISO variac and not actually into the line, the AC outlet. So it saves me one step of troubleshooting, because you'll see as I vary the current level here on the resistance decade, you'll see the line voltage drop, and that's due to the increase in current. So now we're almost driving 200 mils of current, and as you see, it's nice and stable at around 200 volts there. And as I crank this down, in other words, increase the resistance, cranking down the milliamps of current draw, right now we're down to around 125 mils. You'll see the line voltage is definitely creeping up. Now we're up to 118, but we're still regulating. So that shows that the unit's actually regulating both ways properly, both a variation in line voltage and a variation in current draw. So it's working excellent. I'll take it all the way up to around 400 volts here now. So that's about as close as I can get it on the high end, and as you see, we're actually maxing out at that right there at 200 mils, and so we have a pretty high draw on the line there, down to 114. So let me take that up a little bit here. So now we're down to about 130 mils, 100 mils. You see we're still regulating nice here. We're dropping it even more. We're up to 119. We're still at the 402. We're all the way down to 50 mils. So this unit's working excellent. The one thing if you look at the schematic here, I circled all the voltages here were very close to being spot on, except on the control tube, the 6DK6. At pin 6, I believe it is, there was supposed to be minus 47 volts, and I'm getting substantially higher than that, and negative higher. In other words, it was like minus 100 or something. And my first thought was, well, that's messed up. That's why I circled it. And the reason I'm getting the variation, the two resistors that I have highlighted, the one above the circle is supposed to be a 1 meg 5%, and the one below is supposed to be 150K. Well, in this unit, and I don't know, my first thought was maybe somebody made a mistake. Now I'm not going to poke in here because this is still on, but there's a 220K in place of the 1, and there's all the way, it's it looks like it's possibly a 6.8, so it looks like a 6.8 meg instead of a 1 meg. I wouldn't think that would work worth a darn, but it's this thing's regulating spot on, so I'm not going to mess with it. I'll monitor it in case I have a problem, but no matter where you crank this up or down at on the current draw, it's regulating excellent. So I'm going to leave those in there, and I don't know if you're having trouble with yours and you can't seem to figure anything out, you could maybe try that. Here, I'll try to zoom in a little bit. Here you'll see that the one is a 6.8 meg and the other one is right here, a 220K, and those are not correct according to the schematic, but everything else in here was right. I'll show you a few other things I did other than the standard recapping. I increased the filter caps to 100s over here on the two that are in series. I also added inrush limiters over here. Both this one here is in series with the line, and this one here is actually in series with the B+. This is a 1 amp 110 ohm, I think it was 110 ohm, possibly a 220 ohm ametherm inrush current limiter, and this one here is a 3 amp, and that one is necessary because the line fuse is a 2.5 amp slow blow, so I had to go up to 3 on this, and I forget exactly what it's limited at. I think it's 110 ohms if memory serves correct, which would limit, in theory, the whole machine to around 1 amp of inrush surge. But I found it's a little better also to add one, especially when you have a lot of capacitance here, to add one in series with the B+. It doesn't hurt anything. If you look at the data sheets on these inrush current limiters, putting one right after the rectifier in front of the filter capacitors is a perfectly valid location. So I added a second one there. I've also added fusing. This here is around a 500 mil slow blow. That would be in series there again with this B+, which is in series with the meter here, so that way in case there'd be a dead short or some overload, this fuse here would blow and save the high voltage windings, or in case one of the diodes would short. And let's see, what else did I do? Well, I mean, obviously I changed a lot of resistors too, that were, especially the ones on the 6L6s, are all brand new. I also added fusing here. One of these fuses, the screen voltage winding up here, that's a very, very low milliamp fuse. The calibration pots for this Knight KG664. The one on the left, looking at this from the bottom, is the high voltage one. This one is the one you adjust for the 400. The one right next to it that's further in on the chassis here, this one here is the 0. This adjusts for the low voltage part of it, taking it all the way down to 0. You want to make sure this isn't negative, otherwise you could reverse polarize the output capacitors on this. So if anything, you want this to be a little positive. I mean, a volt or two is not going to matter. I try to take it as close to 0 as I can. Okay, the final step on fixing up one of these power supplies is you have to make sure that you have a reasonably balanced set of 6L6 pass tubes. So right now I have a current meter hooked up to both these first two 6L6 pass tubes, and as you see, these are not excellent balanced. They're, I guess, fair. For example, this one here is pulling about 45 mils. This one here is handling a little less, around 39 mils. And that's just at whatever load I have set up here, which is, it's around 300 volts here, and you have around 150 mils of milliamps of current. So as you see, these are not balanced excellent here. So what I'm going to do is write down what each one is drawing, and I'll pull out a few more and see if I can get a set that will be pretty close to being evenly matched, because otherwise what happens is you spread the load unevenly between the tubes, and the ones that are taking the load are going to wear out a whole lot quicker, and that's really not how the power supply is designed. For example, here I swapped around the 6L6s to put the other two tubes that I didn't get a chance to test yet into these test sockets, and this one here is regulating at around 38 to 39, and this one here is up around 46 to 47, so they're again not very well matched. So this wouldn't work ideally, at least in terms of spreading the wear around the 6L6s very good. So I'll mark these, and then I'll dig out some more and see what we can come up with. Okay, here's an example of two tubes that I matched using another method that I have, and they match perfectly than the other method, and as you see, they are identical in current draw in this power supply. So that's what you want out of all the tubes in your unit, whether you use 2-pass tubes or 4-pass tubes. You want them to be matched. And here's the other set that I had matched using my other matching method, and as you see, this set is also matched perfectly in this power supply too. So all 4 tubes are actually identical, and this is going to be an outstanding unit that'll last for a long time. I thought I'd show another little aspect of the power supply. Okay, so right now we're at 150 milliamps of current. I set it at 300 volts, and I'll show you the ripple. You're only at 8.1 millivolts of AC ripple, so it's extremely low. This power supply is meeting all its specs. It's performing flawless. What we'll do here is we'll crank it up a little bit here. Try to get it up to 400 volts. I don't want to take it above the 200 mils here. Looks like that'll be right about on here. Okay, that should be about 400 volts. We're at 200 milliamps of current, which is the maximum continuous rating of this power supply. And as you see, we're only at 9.1 millivolts of AC ripple. So this thing's performing excellent. What we'll do here is we'll turn this, we'll turn the amperage down on this. So there we are. We're at about 130 milliamps. As you see, we're still spot on at the 400. Turn it down to 100. Still spot on at 400. Down to about 75 milliamps. Still spot on at 400. Take it down here. This is right about 50 milliamps. We're right on. As you see, the ripple settles back in at 8.0, 8.1. So, I mean, really you could not ask for anything more. This is an outstanding unit if you work on tube stuff or you try to model tube projects. I like it a lot. I like the 2-tube units fine too, the ones that use 2 6L6 pass units such as the ICO 1030 and the Heathkit models, the IP17, and I think another one's a PS2 or something like that. They're a nice unit. Nothing wrong with them. You get more current out of these, especially from an operating standpoint. You know, some of the ones are more conservatively rated than others, but you can run 200 mils on this and you're not going to have a problem. Whereas the other stuff, your 150 is really pushing the limits of those. At least in my opinion, it is. So I'm very happy with how this turned out, and hope you got something out of my tips on how to fix one of these up and have it perform the best, and also add some safety by fusing some of the windings and adding some inrush current limiting to the different areas of the circuit, both on the primary and also on the B+. Okay, thanks a lot. Bye.